In this video, I'd like to talk about the math question of the day for Friday, July 28th, 2023. And with this problem, we have a sinusoidal equation. 16 multiplied by the cosine of 8x minus 2 is equal to 6. And we need to solve for x. And questions like these are typically seen in either a pre-calculus class or you might see this in a trigonometry class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you've attempted the problem, let's start working through it. And the general strategy with these sinusoidal equations is to first solve it for the sinusoidal term, either the sine or the cosine. So let's start by adding 2 to each side so that we get 16 multiplied by the cosine of 8x is equal to 8. And then from here we can divide both sides by 16 to cancel out that multiplication. And on the left hand side we just get the cosine of 8x. And on the right side we get 1/2. Now once we solve it for the sinusoidal term, this cosine term, then we can use the unit circle at this point. So remember with the unit circle that it's plotted on the coordinate plane, the xy axes, and the radius of this circle, the distance from the center to the edge, is 1, which is why we call it the unit circle. And you might remember that the xy coordinate on this circle, at a point on the circle, the x coordinate, if this angle is theta, the x coordinate can be shown to be the cosine of that angle theta, where y is the sine of that angle theta. Now, we're looking for when the cosine is equal to 1/2. And remember, the cosine is the x value. So we want to know when is the x value at 1/2. And like I mentioned, since this is the unit circle, this point right here would be at the point 1, 0. This point is at 0, 1, and so on. But an x value of 1/2, or a cosine value that's equal to 1/2, would be right about here. So we're looking for angles right there and somewhere right there. Now, with the cosine, you might remember that the cosine of 60 degrees is equal to 1/2. Since when we have a 60-degree angle, we end up with a 30, 60, 90 triangle, where this is our 60-degree angle, this is 90, and this is 30. And since we know the hypotenuse is 1, the shortest side is always half the length of the hypotenuse, and then the middle length side in these 30, 60, 90 triangles is the square root of 3 multiplied by the small side. So this becomes root 3 over 2. So if we wanted the sine of 60, it would be root 3 over 2. But we want the cosine. We want the x value, or the horizontal value, which you can see is 1/2. Now, if we want, we can also find this measure in radians, since 60 degrees and pi over 3 radians are the same thing. So the cosine of pi over 3 is also 1/2. Now, notice with the cosine value on the unit circle, the x value, that they're positive on the right half of the plane. And so at 2 different points on the circle, we will get x values equal to 1/2, meaning that there are 2 different ways that we can approach this solution. One is to figure out this positive angle solution and all the multiples of it. And the other is to figure out the negative angle solution and all the multiples of that. So let's start with the positive solution. That's when the angle is pi over 3 radians, or 60 degrees. We can do it in either radians or degrees. Let's do it in radians. We basically know that this angle needs to be pi over 3 for one of the solutions. However, we could have multiple solutions. We could have infinitely many solutions. Since if, let's say, we're right here at this angle of pi over 3, we could then just add 360 degrees, or 2 pi radians, to get all the way back to this angle again. And we can add 2 pi radians as many times as we want. So this angle here would give us an output of 1/2 infinitely many times. The first one at pi over 3, but then if we just add in 2 pi times by n, we will get our infinite solutions, where n can be any integer. So it can be a negative number or a whole number or a positive number. It just has to be some type of whole number. And this will account for all the different possible solutions, where we can see if we plug in 0, we just get that first solution at 60 degrees or pi over 3 radians. Now, to put this in terms of x, notice that our angle, this entire input, has to be pi over 3, or we can also add some multiple of 2 pi to that, so that we get an output of 1/2. But we know that this input here is also equal to 8x. So we have to set 8x equal to our solution set, pi over 3 plus 2 pi times by n, so that we can put everything in terms of x. So at this point, the approach is just divide everything by 8. We get x is pi over 24. Let me rewrite that a little bit neater. Plus 2 pi n over 8, and 2 over 8 is 1/4. So we get pi times by n over 4. So this right here is one part of our solution. That's when we're looking at this positive angle here, where we get an output of 1/2 for our x value. But remember, like I said, if we look at the negative angle scenario, we can also get an output of 1/2. Since in that case, if we do the cosine of minus 60 degrees, this is also equal to 1/2. Or if we wanted, we could do the cosine of minus pi over 3 radians, since that's also 60 degrees. So we need to come up with our second solution set to account for these negative angles, but we'll take a very similar approach like we did here. Except in this case, we'll say that 8x, our input here, has to be negative 60 degrees or minus pi over 3 radians. But we can again add these multiples of n. We can do plus 2 pi n, and that just accounts for the fact that we can go multiple times around the circle and end up back at the same point if we just add 2 pi radians or 360 degrees. So we again will have this infinite solution set, and to put it in terms of x, we divide everything by 8. We get minus pi over 24 plus 2 pi n over 8, which we know is pi times by n over 4. So this is our second set of solutions, and now we have both. So both of these combined are the set of all solutions to this sinusoidal equation here.